Welcome to Learner's Point, everyone. Let's start with the normal Aldol reaction before starting with the mechanism. So first I will draw a basic reaction of Aldol. So what I will do is I'm gonna draw. Oh, this is too bold. Let's make it small. So this is first aldehyde molecule, right? I will add it with another aldehyde molecule, and both of them will give a result of an aldol. So this is your aldol. Remember that over here is an H and over here is an alcohol group, that is hydroxy, and in the reaction mechanism what we add is NaOH. You can also write water along with NaOH, but you don't need to write it because in NaOH there is already some amount of water present. All right, so this was your basic reaction where we add one aldehyde molecule along with another aldehyde molecule and it gives an aldol. The name of this aldol is 3-hydroxybutanol. So remember one thing, that aldol reaction always adds up to your number of carbon atom. For example, earlier you had only 2 carbon atoms in one molecule. Now you have 4 carbon atoms in one molecule. So let's start with our mechanism. The mechanism involves the formation of enolate ion in the first step. So let's make the enolate ion possible. Right, starting with I hope it's clearly visible to you. So this is your aldehyde molecule. Now in this aldehyde molecule, you know that oxygen is very negative. So we draw over here as a negative charge. No, not now. Let's make some rearrangement, and then as you know that the terminals have 3H. So I just want to focus on one of that. So I'm drawing those one of the H's. So this is your H, and remember we have added NaOH. So NaOH in water, what happens? It dissociates into what? Na plus and OH minus ion. So I will need the reference of OH minus ion. Reference means I need an help. OH minus. So this OH minus happens. This OH minus atom attracts this particular hydrogen. And as you know, this oxygen is very negative, so it also tries to pull the electrons towards itself, and thus the second carbon feels a weak force for this particular hydrogen to bind it along. So what it does, it leaves this hydrogen, but it leaves it in a very unique way. You know that carbon is more electronegative. Since the carbon is more electronegative, it pulls the atoms of hydrogen towards itself, and the hydrogen leaves as H plus and OH minus. So H plus and OH minus forms what? Water. We are not interested in that, so let H go away, and this leads to a formation of what? Here you will get a double bond. On the upper side you will get as O negative because oxygen has pulled one electron, and rest of the things is remain the same. And this is what? This is your enolate ion. Now don't forget this enolate ion, because this is a very important part in the upcoming reaction. Now what I will do, now we will start with the another molecule of the same type, and that will be your aldehyde, because you know there are numerous numbers of aldehyde present in the reaction. So we will take another one of those. Now what I will do is I will do the same what I have done in the previous reaction. The oxygen is very electronegative, so oxygen tries to pull its electron towards itself. The shared pair of electrons is tried to pull upwards, so this will create a slightly positive charge on the lower carbon atom. It will present a slightly positive charge. Now because of this positive charge, the electron, the double bond present over here, will try to get over here, because presence of double bond means presence of large amount of electron density, and electrons are negative, so this somewhat has a negative charge. So this point, this double bond tries to react with this central carbon atom, and now what it leads to, let's see what it gives us. So first I will draw this same compound with red color, C double bond O, but it no longer remains as a double bond because it has turned into what? O minus. Alright, now here I should write H, but now I will not be showing the H, okay, because in bond line formula we don't show H. Alright, so let's draw the other molecule. Yeah, it goes like this, and over here what you have an enolate ion, that is O minus, so I will write it as O minus only, and here you get your H. Now as you can see, earlier you had a double bond over here, but now that double bond no longer exists because that double bond is used for the formation of bond over here. So the double bond no longer exists, and you get a compound like this thing. Alright, now as you know, the moment this double bond shifts, the moment this double bond shifts to this point, the electron density over here shifts to this particular point. Alright, so what I'm trying to tell you is you will get a result like this. You get me? And now do you remember that this whole compound has given one hydrogen for the formation of OH minus ion? So that hydrogen will come back to it over here from here. This will be an H plus, and this H plus will join this compound, and this will finally give you the product as, I'll draw the product on the upper side. Over here you have H, over here what you got? C double bond O, and over here you get as OH. So this is your product. You saw the whole mechanism. Now let's revise it again in short. Right. The first step is the formation of enolate ion over here. So the enolate ion is formed with the help of electronegative atom. The oxygen pulls the electron towards itself. Meanwhile, the hydroxyl group, that is OH minus 1 we got from the NaOH, tries to pull this hydrogen towards itself, and thus it leaves the electron density to the neighboring carbon, and it leads to formation of double bond with an enolate ion. Alright, so this is your enolate ion. Now we will look on to the another aldehyde molecule present in the same beaker. So this is your another aldehyde molecule. Now this aldehyde molecule goes with the same reaction, because oxygen is very electronegative. It tries to pull the electron towards itself, and when the oxygen pulls its electron towards itself, it creates a electron deficient site over here. Now this site is attacked by the enolate ion, and this double bond shifts to this carbon, and with this you get a compound like this, which is your 3-hydroxy butanol. I hope the mechanism is pretty clear to you. So now you may ask me, from where does this H came from? So I will tell you that you have used one OH minus ion, which was your catalyst in the start of the reaction. So this time we are going to regenerate those OH minus catalyst. So now you see you have made the formation of HOH, that is water. Now in OH, oxygen is negatively charged, so it definitely tries to pull this electron towards itself, and Now you can see that this is an enolate ion. So this enolate ion has a negative charge, so this tries to pull this hydrogen towards itself. So thus it takes the hydrogen back from the water, and your OH minus group, that is hydroxyl group, is regenerated. That's it. So during the time of representation, you may represent this whole thing in this fashion, where HOH is a water molecule, the OH minus tries to pull the electron towards itself, and the hydroxyl group, the enolate ion, gives the negative charge to the neighboring hydrogen, and thus it leads to the formation of OH. Thank you for watching.